Hey everybody, it's Alan. Today's tutorial is going to be on how to create a running crowd simulation using Cinema 4D, Xparticles, and Mixamo. So here's a look at what we'll be creating. Yeah, run for your lives, right? Okay, so that's a lot of fun. Let's see how we can create that. If you're not familiar with Mixamo, Mixamo.com, it's I guess a recent Adobe acquisition, and it's a place where they have 3D animations, motion capture animation. You can upload your own models and have it auto-rigged and download the animated versions of those things. So I believe if you're a Adobe Creative Cloud user, you can go in here and get some free access to stuff, at least temporarily, I think. But once you're inside, you've got access to the characters, and they've got quite a bunch of selections here for sci-fi, some fantasy stuff, some animation cartoony guys and gals, and animations. So running, jogging, lots of game cycles, shooting, dodging, all that jazz. So once you go through and pick some characters, here's several that I chose. You can select your guy or girl or creature, whatever. Go to Find Animations and plug in whatever motion you'd like for this person to be doing. So obviously this is a running crowd, so we'll select running. And here's 21 frames of an animation. It's just a loop of this guy running. So you can add this to your pack and download it as an FBX, and that FBX file format will import into Cinema just nicely, and that will be the basis of everything. So one important thing, relatively important, is to make sure in place is selected. If not, your character is going to start in one spot, and 21 frames later he's bolting, he's elsewhere. So that'll make it a little bit difficult inside Cinema. Well, not really difficult, but it's just one more thing we got to deal with. So check in place and save it, download it, and once you do, then you get a folder of FBXs, and you can select one FBX and drag it into Cinema. And these import settings, I just say whatever, default, okay. And the first thing you'll notice is that the character is kind of transparent. So I'm going to select all my materials, and under the Basic tab, go to Transparency and disable Transparency. All right, so this is 21 frames of, we got the in-place, the non-in-place version. Let's fix that. Under Window, go to Timeline F-Curve. And the joints here, that's all this animation. That's where all the motion capture lives. The hips, I think position Z is what's responsible for our character moving forward. So we can just select position Z and disable that. And keeps all the keyframes, but Cinema just disregards them. So now we should have a character run. Yep, there, he's running in place now. Okay, cool. So the whole idea here is that these joints are what's housing the actual mocap data, and it's deforming all these pieces of geometry by way of a skin deformer. So there's several pieces here, and it's all pretty complex and taxing, I guess, inside Cinema, especially once you have a whole crowd of people. The idea here is to simplify the motion of running into one mesh, and we can take that and duplicate that and have that be our basis for the runners. So how can we do that? Let's start by taking all pieces of geometry and smashing it down into one, and we'll do that through a connect object. So come over here and select connect, and before we do that, you'll see that the weld option is on, so let's disable weld. If we turn it on and carry on, it's just going to introduce some weird artifacting, and it's not going to look so cool. So before we drop in our pieces of geometry, the Mixamo characters that come in as FBXs have some extra baggage that we want to get rid of. Under the eyes, it has poses for the different eyes that are invisible or just disabled visibility. We don't need these. That's just extra stuff for the connect object to calculate, so let's just ditch them. Select and delete for the eyelashes and the body. I believe everything else is these top level pieces of geo. So cool. Let's select all those pieces and drop it under the connect. And now what this allows us to do is, let's go ahead and rewind to the beginning and right-click on our Connect object and go down to Current State to Object. And that's going to make one piece of geometry with all the materials and everything, except it doesn't move. But this is a good starting point. Let's go ahead and rename this guy Run Dude. Dude Run. Dude Run. Okay. And let's disable that from visibility. Let's kill that, and let's come back here to this Connect object, because again, we want to take this animation but lose the joints, and we've already got our one piece of geometry. So how do we transfer that information from the joints to the mesh? We're going to use a point cache tag. And the point cache tag, if we right click on an object and just say character tags, point cache, this is one of my favorite tags. It's super cool. It's not going to let us operate on the Connect object itself, because the Connect object is a generator, technically. It's looking for deformable or editable geo. So one way we can make this Connect object editable without having to hit Command C or to collapse it down, not Command C, just C, we can use a correction deformer. So let's select the correction deformer, and let's group these two guys together and put the point cache tag onto the correction deformer. You'll notice a little spinning beach ball. It's the correction deformer going through all that bit of geometry and storing it inside here to make it one editable mesh. So if we go through now and say select polygons, we can select, you know, these pieces here and do something weird with it. And it's going to look awfully strange when you play it back. So we don't want to do that. We actually just need it to have point level access so that the point cache deformer can read it. So put that point cache tag onto that correction object, hit store state, and now it's all live here. You can hit calculate. And now it's transferring all the motion from the joints and that deformed mesh into this one tag, which is roughly 9 megs. Cool. So now we can take that, put it on the Dude Run, the single mesh that we created earlier, and let's copy that, paste it into a new scene, and when we hide it, unhide it from visibility, or invisibility, we can hit play, and we've got our motion. It's only running for the 21 frames that was cached, of course, so under that point cache tag, there is a loop feature. So we can say loop 100 times. And now it's just going to loop, 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 loop. But the cool thing is that we can take this scale and change it up to make it, say, 150. And now we have a dude who's running faster. Or if we slow it down to 50, he's running much slower. So, you know, you can take this guy, one piece of geometry, and start duplicating it. Now you have 2 runners, and that second runner, I want to have that guy run twice, a little bit, 1.5 times faster. And you can offset the start of the animation too, so now you have 2 seemingly different random runs. Okay, so you'll do this whole process for each of the characters that you want to use. So let's go ahead, and I downloaded those 7 from Mixamo, so you just repeat that whole process. And this is the base for our crowd. So how can we get this guy to run forward, get him to run in a position, or I guess we could do a spline, we could do, you might be able to do some MoGraph stuff to it as well, but we're going to use XParticles because XParticles is way cool, and it will do a lot of the heavy lifting for the simulation for us. So let's go ahead and add in an XParticles system, and we've got all these categories for all the elements that make up the XParticles system, and the one we want is emitter. We need to start with that. So let's hit play, and it's generating particles. Let's go ahead and disable the visibility for our dude. And the whole idea here is that we're going to use these particles, and we're going to shape them and have them behave in a certain way, and these points are stand-ins for the geometry. And so once we're happy with the points, then we can bring in our geometry and put the geometry where the points are, and then all of a sudden we'll have our running crowd. So let's shape the particles first. So under the emitter, I don't need guys on top of each other. We're all on the same playing field, level playing field. So height, bring that down to 0. And we don't need quite so many particles. It's not a marathon. We're just running away from something. So maybe some dude farted, who knows. All right, so this is small particles. I can't see really anything, and I'm sure you can't either. So I'm going to bring in a sphere, and under the XP system, there is under generator objects, there is a generator object that will take whatever we drop underneath it as a child and place it where those points are. So obviously this sphere is entirely too large. Let's say 20. And let's also take our emitter, and under object, let's increase the width to maybe 1,000. Okay, cool. So in some parts of these here, you're seeing that the spheres are overlapping. So let's help offset that. And under emission, we can go to no intersection. And so depending on what this radius is, XP is going to try to space out each particle at least by this much so that they don't overlap each other, or they don't intersect with each other. Now there's probably going to be some intersections up here when we start, in fact, they're not really doing anything right now, but if we take our object, our emitter, and change up the H angle, the horizontal angle, I guess that's what that is, horizontal. So they're not intersecting at the point of birth, at the emission point, but because we have introduced some, they're no longer shooting straight forward, they're moving left and right a little bit. You'll see that these spheres are intersecting each other. So let's fix that. Under the XP system, there is a dynamics object here called PP collisions. And PP collisions is what allows the system to see itself. Under self collisions, that's enabled. So, but we are still getting some intersecting here. Why is that? Well, under the XP emitter, right now XP only sees the emitter, the points. It's only dealing with points right now, and that point, each point has a radius of 1. So if we increase this to match up with what we have here on the sphere's radius, so that's 20. Let's go back here to the XP emitter and change that to 20 as well. And now we should see some bouncing happening and no intersections. Okay. So that'll be handy later on down the line when our runners are colliding with each other and not intersecting each other. Okay, cool. Let's bring in, let's take our geometry and let's put it in place of the sphere. And this is important because the next thing is that we're going to want to match up the character running to his foot contact, or their foot contact, to the ground. But we're having some problems here. The guys are entirely too large and they're facing the wrong direction. So the easy fix is to take the dude run and Option G, put them under a null, and then reselect that mesh and go back and spin that 180. And now we should have our guys moving and facing the right direction. But you'll notice our viewport playback is way slow. So under XP generator, we can go to the object tab, and under clone type, set it to create render instances. So now we should be at a little better viewport performance. But he's a little too large, so let's take our dude run and go to the coordinates tab, or go to the object mode and then switch over to the scale tool and then just size it down, maybe somewhere in here. Okay. I'm going to also just decrease the number of particles to 1. And why am I doing just 1 particle? I'm going to concentrate on how his feet are moving across the ground. So you're seeing there's some slipping there. And I'm also getting a duplicate before. That's 1 particle. This guy is the actual geometry, but we can't disable his visibility, because if we do, the particle goes away. So what I'm going to do is just take that null and push it back out of frame, and that'll help us just focus in on 1 particle at a time. So here's 1 particle, and it helps to have the grid on here for this section. So what we're going to try to do is match up the particle speed, the actual particle velocity, to the playback speed of the animation. So you could either offset the animation, the scale, and speed this up or slow it down to match the particle's velocity, or you could take the emitter and match up the speed to get in sync with the playback. So I'm just going to play with the speed here. And I'm just going to focus in on, the feet right there. So they're sliding, it looks like, and this is going to be a little bit of trial and error. So I'm just going to go through a couple extremes here and see if there's anything that jumps out immediately. So 400 frames. That's getting closer. Oh, but he's sliding left and right because we have the emitter with this H angle set to 45. Let's bring that back down to 0. We'll bring that to, just normalize that for right now so we can focus in on the feet contact here. Okay. All right, so looks like let's go back to emission, and looks like it's a little bit slow, so let's try 420. There we go. So you'll have to do this for each of the characters that you're going to introduce into the scene, just so that they get the proper foot contact on the ground and they're not sliding forward or backwards. Okay, so that's looking pretty cool. Let's go ahead and bring in our, let's say 20 guys at once, and then the object tab will say 45 degrees again. All right. So now that we have the feet making the proper contact, these guys now are all sliding left and right, and you can see that all the runners are facing forward. They're not actually facing the direction that they're running. So we can fix that if we enable one thing inside the XP emitter, and that is go to extended data and use rotation for the particle rotation data, and set the rotation mode to tangential. There you go, whatever you said. And now all these guys are running or facing the direction that they're running. So that's pretty cool. Let's accentuate this a little bit more. Let's say 60. They're bouncing off of each other, changing direction, and that's looking pretty good. Let's introduce some obstacles. I'm going to make some cylinders here. Put this kind of on the ground. There we go. That's one. Let's make another. Let's make another. Okay. Now, in order for X-particles to avoid penetrating these cylinders, we're going to need to use an object inside the XP system, and that's the motion modifier, avoid. This avoid object allows us to drop in these objects that we want to have the particles disregard and move around. So I'm just going to drop those cylinders in there, and when we hit play again, let's actually come back to, instead of our dude run, let's drop in our sphere again and rewind. And we're getting particles that are generating away from our emitter because the sphere is parented to the null, which is back here, and so that difference between here and here is what's causing that offset. So let's go to the sphere and just reset PSR. We'll go through here. We can push that button or just zero out X, Y, and Z there, and now our particles will start from the same spot as our emitter. Okay, so let's increase the sphere size a little bit. All right, they're penetrating. So there is something inside the avoid object called object shell. And right now, the avoid object is registering the cylinder mesh itself, all these guys, but we can actually add some pad to that, and that's what this object shell is. So once we start increasing this to like 2, we're giving a little bit more pad around the cylinder object itself, and so now you'll notice that nothing really comes down inside that area anymore. Okay, so we're getting some intersection here because that I think our emitter size is not matching up with our sphere anymore. Our sphere is 40 centimeters and our emitter size is 20. So we're just using this to see, to make sure that no geometry is entering inside this, the cylinder here. So I'm going to take my sphere, pull that out, and put the dude run back in and let these guys go. Okay, so now these guys are running around. like crazy. Let's bring our emitter down to 10. Okay, so they're not really running in here and they're basically following the direction of this initial horizontal angle. So I'm going to set that to 45, and we're going to introduce a modifier in here called, under motion modifiers, we're going to go and select turbulence. And if we say turbulence, the noise type to wavy turbulence, this is going to give us a little bit more randomization in their motion path, their direction that they're heading. So it's a little more chaotic, and I think it's a little cooler. But you'll notice that, oh, we forgot to do one thing. Turbulence, we only want to limit it to the X and Z axis. Otherwise, you're going to have these guys running off up and down in space, like that guy is going down towards, you're going to hell, buddy. All right, let's turn off Y-axis. And now that'll just limit it to left and right motions. Okay, cool. And these objects, position these guys where you want them to move. And we can increase the turbulence scale and the strength, maybe. And that should get us a little bit more, some craziness going on. Here we go, get some guys going in there. Run away, run, run, run. I think our avoid, I don't know if that's set too high, 1.3. Really like to get all this in here. Here we go. These guys are now moving. They're just scattering. That's kind of cool. So yeah, you'll just have to play with the turbulence settings, the avoid, obviously where your obstacles are placed, and also the emitter, how far out you want these guys to run. Now that everybody's running straight, and then we have the turbulence providing some of the randomizations of where these guys are going to run to. So those are all the different variables. Let's go ahead and look at, I think, what else did I want to add in? Oh, once we get all the other people in there, let's go ahead and open up this other scene. Crowd Sim 1. So here is the same idea, but we've got several different pieces of geometry here now. And they're all avoiding these obstacles and each other, thanks to X particles. But you can do some crazy stuff now. I mean, you've got this simulation, you can cache it, and you can change out the various clothing colors just to get some more variation. But this one thing is kind of cool. So we have turbulence. I added a direction deformer to kind of help out with some of the randomness. But this follows surface. Because these are particles and we're telling the particles to follow, we can tell the XP system to follow a surface. So this floor right now is very, it's flat. So if we say enable and tell this follow surface to follow the ground geometry, which is what this is, we can actually start to alter the ground and introduce something like a bend deformer. And again, because these are particles, they're just going to do what they're told, and they're going to follow that surface, and that surface is bending, and now you've got this like cool Inception thing going on with these guys avoiding the cylinders, avoiding each other, and running up this hill, running up the wall. Cool. Or you can do a twist deformer, and now they're doing some weird thing, some vortex deal. So it gets pretty abstract, it gets kind of crazy, but yeah. That is pretty much the technique to getting a running crowd simulation inside Cinema 4D using X particles and Mixamo mocap data. I hope this has been helpful. I hope you guys enjoyed it. Send me some comments on at Twitter. I'm on Twitter at Demafleez, Demafleez. You can shoot some comments down below. I'll try to answer those. But yeah, shoot me something with what you made. I'd love to see it. And yeah, hope it's been helpful. So catch you next time. Cheers.